8M 7, lesson 21, volume of composite solids. This is nothing more than using your critical thinking skills along with everything else you've learned to find the volume of things that are made up of more than one shape. So, what am I talking about? What is the lesson talking about? Let's check it out. So, finding the volume of composite solids. What is a composite solid? That is a solid made up of multiple parts. These parts may include prisms, spheres, cylinders, cones, pyramids, truncated cones, truncated pyramids, maybe some other objects even. They're going to be put together in various shapes. And they also may include things like half or quarter objects, like this, which is a half cylinder, right? If we drew in the other part of this cylinder, it would look like this, right? We'd have a full cylinder, or this would be a full sphere. Be the other half. This is here as a quarter cylinder, and this would be our full cylinder, looking something like that. All right, but here we're just talking about a quarter cylinder. So all we're going to do today is we're going to run 4 examples I got off the internet. And working these 4 examples, you should be able to use that same kind of thinking to solve problems that are going to be given to you in lesson 21 problem set. So these examples, I just pulled them off the internet, and we'll solve those, and that should get you ready for your homework, or maybe give you some ways to think about some of the homework problems. All right, here's problems. Well, let's first just talk about the one in the lesson today. So in the lesson today, you're presented with this example, and here we have 2 objects. If you break this down, you can see that we have a prism here, right? And it doesn't show you this back side of the prism, but we have that box, and then on top of that we have we have a half cylinder. So this is a half cylinder. And so for our half cylinder, our cylinder formula is just our base times our height, but a half cylinder is a half of the base times the height, because it's just a half of the whole volume, right? Because if we had a whole cylinder, it would just be, we'd find this base, the area of the base, and then we'd multiply it by the height. But we only have half of that. So we're going to have to multiply our answer by a half. Now our base is found by, well, they don't give you the base, so we have to find our base by saying pi r squared. So if we have that base circle, our radius is what? Well, we know that it's 4 from here to here, or 4 from here to here, so that from here to here, let's draw that in a different color maybe. So our radius here is just a 2, which is a 2. Those are all 2s. So our radius is 2. So pi times 2 squared times the height, which is 15.3. Times a half. Okay, there's our half, our base, and then this is our height. So let's multiply that out. If we go a half of pi times 2 times 2, which is 4, times 15.3. So a half of 4, let's change the order. Let's multiply the half by 4 first. So that's 2. 2 times 15.3 is 30.6. So we have 30.6 pi, and that is our half cylinder. So that's our half cylinder. Now let's just do our box, our prism. And the prism is, again, base times height. And our base is a rectangle. So 4 times 6. That's our base. And our height is 15.3. So that's the area of our prism. So that's 24 times 15.3. I'm pulling out my calculator, multiplying that out, and I get 367.2. So my answer is 30.6 pi plus 367.2 cubic feet. If you want to estimate that, we can take 30.6 times pi and add to that our 367.2. And that, if we round it, that comes out to about 463.3 cubic feet. That's our estimate. Now, as you see, we're just going to, the whole key is finding your two objects, looking at your formulas and calculating your volumes, and then just adding them together. Let's try another one. And sometimes you might have to subtract. We'll get to one of those in a little bit. Now, what is this? In this example, I got this. Here's my citation. I always like to, when I pull things off the internet, like to give credit to the websites that create these examples. You can go there and you can find this example for yourself. We have to find the area, the volume, sorry, of the cylinder with this cone on top. So my cone is equal to 1/3 of my base times my height. And my base is this circle, so that's equal to 1/3 pi r squared times my height. So that's equal to 1/3 pi times 5 squared times my height, which is 13. Now my cylinder is just equal to my base times my height. So that's, my base is pi r squared. Same base on that cylinder. This base here is the same for this cone and the cylinder, times height. So that's equal to pi times 5 squared times 2. So if we multiply that out, we get 25 times 13 divided by 3, 108 1/3 pi. And if we want to estimate that, we can, it comes in around 340. This is an estimate. That's my estimate. We'll call that EST. And down here, 5 squared is 25 times 2 is 50. So this is 50 pi. 50 times pi equals 157. About 157. So if we add that to our 340, we get about 497 cubic centimeters, about. That's my estimate. Add those together and you get your final answer, 497 cubic centimeters. So again, and what do we have here? Let's look at our other example. Let's do this one in pink. So this is a half sphere and a cylinder. So let's look back and let's do our half sphere. A half sphere is equal to a half of 4/3 pi r cubed. Well, if I take a half of 4/3, I can take my 2 and cancel those, cross cancel, and I get 2/3 pi r cubed. Now my r is what? My r is the same as my r of my sphere, or of my cylinder, so that's 5. So we get 2/3 times pi times 5 cubed. So that equals, this is 125 times 2, that's 250 over 3 pi meters cubed. I shouldn't write it like that. I should just write it meters cubed. Let's just do it the right way. Now, my cylinder is also very straightforward. Same thing, pi, my base, which is, there's my base, pi r squared h. We have pi times r squared times h, which is 8. 8, so this is 25. 25 times 8 is 200, so our answer is 200 pi cubic meters. So if I add those together, my answer is 250 divided by 3 plus 200 times pi, and I get about 890 cubic meters. Very good. Moving right along. Now on this next one, we get a little bit of subtraction going on here. So what do we have? We have this cube that's 5 meters on every side. 5, 5, 5, 5. It's a big block that's 5, and we'll just call it 5 centimeters. And then we have cut a hole out. So in the middle, we cut out this hole that has a 2 centimeter radius. So it's actually a little bigger than it looks here, 2 centimeters, because that'd be 4 centimeters all the way across. So what are we going to do? Well, we have to find the volume. This is a subtraction problem. We're going to find the volume. So this is homework help, by the way. You can pause and try at any moment. If you want to pause and try both, I encourage you to do so. But the volume of a cube is the volume of a cube is equal to the side cubed. It's length times width times height. They're all the same. So that's 125 cubic centimeters. Now we need to subtract from that this cylinder. And what is the height? The cylinder, the volume of the cylinder is equal to the base times the height, pi r squared h. So this is our base, this circle, and our height is this length. Right? So that's equal to pi r squared is 2 squared, and then our h is 5. So that's equal to 4 times 5 is 20 pi centimeters cubed. So we're going to take our square, or our cube, and we're going to subtract our cylinder. So our answer is really 125 minus 20 pi centimeters cubed. But let's get an estimate for that. So I'm going to get out my calculator and go 125 minus 20 times pi, and that equals 62. Estimate of 62.2 cubic centimeters. That's what's left. You started with 125 in that whole block of ice, and you bored a hole through it that had a radius of 2, and the amount of ice left is 62.2 centimeters. Okay, Let's do this last one here. This can be done as a subtraction problem, but I like to look at it as just taking, 3/4 of a cylinder. Right? We could take the whole cylinder and just multiply it by 3/4, and that's going to be the volume that's left of this. What is this? Like maybe a park bench, or what does that look like to you? Anyway, the volume of a cylinder is we're going to take 3/4 pi r squared, our base of our cylinder, times our height. So that's simply 3/4 times pi times 5 squared. We used a lot of 5s in this. A lot of 5s appeared in our problem sets today. Times 12. Before I start multiplying, I'm just going to reorder this in a way that makes the multiplying a little bit nicer. 3/4 times 12 times 25 times pi. So 3/4 of 12, 3 times 3 is 9. 9 times 25 times pi. 9 times 25 is 225 pi centimeters cubed. If you want to multiply that out and take an estimate, you can do that and say 225, 225 times pi, and you would get an estimate of 706.9 centimeters cubed. Let's lay down some happy cats. And so this is, this is your problem sets, thinking about adding or subtracting composite solids. And it's not, it's just an application of what you already know with a little critical thinking layered on top. So we will leave you with that. And tomorrow we change it up a little bit, and we're going to use some of our calculations in our formulas and such, but we're going to be doing something a little bit different. It's actually, gosh, I don't want to use this word, but it's kind of on the beginnings of calculus. Some of the principles we'll be learning in lesson 22 and 23. So get excited, and then the year will be done in 2 more lessons. Over and out.